means f dash of 1 equal to 0. So in this case we should find the value of a. So therefore we should differentiate this function. So here what we are getting 4x cube minus 62 into 2x plus e, because the differentiation of x is 1, differentiation of 9 is 0. So therefore now f dash of x is equal to how much? So clearly it is a 4x cube minus of 124x plus e. Okay, now what they given? They given f dash of 1. They given, it means that at x equal to 1, right? So it is a the given function attains its maximum value. So this means that f dash of 1 equal to 0. So therefore I will take f dash of 1 equal to 4, because 1 cube means 1 minus of 124 into 1 plus e. So what is the value of f dash of 1? 0, because here it is 4 minus 124 plus e. So therefore 0 is equal to minus 124 plus 4 means minus of 120 plus a. Take this 120 to this side. So here what you are getting? So clearly the value of a is equal to 120. Okay, this is the value of a, that is equal to 120 for this function. Okay. Okay. The next question, question number 13. Find the two numbers whose sum is 24 and whose product is as large as possible, right? So such type of the problems they may ask for 3 mark in your annual examination. Most of the time in the maxima and the minima there is a 3 mark question on this concept only, right? So they will give the sum and product and they will ask you to find the then they will ask you to find the remaining two numbers, right? So here what they given the two numbers whose sum is 24 they are given, and whose product is as large as possible. As large as possible means the meaning of as large as possible means this function attains its maximum value, right? So to find the maximum value or minimum value we are using the second derivative test to check the given function where is maximum. So for that we are using the second derivative test. So to show this function is maximum we should check its second derivative is less than 0. So according to this, so here we will take let x and y be the x and y be the two positive numbers, right? So two positive numbers. So I think here it is they given the two positive numbers they given. Okay, x and y be the two positive numbers, or here we will take the two numbers they are given, right? Whose sum means we will take sum of these two numbers, that is equal to x plus y is equal to how much? They are given the 24. So from this we will write y is equal to 24 minus x. Is it right? May we write like this? Just take this x to this side. Here we are getting the value of y is equal to 24 minus of x. Also what they have given? They have given the product of these two numbers. So here I will take p is equal to x into y. The product of those two numbers is equal to xy. Now I will write, or I will take the value of y. Then the value of y 24 minus of x. I will substitute here. So here we are getting the p is equal to x into 24 minus of x, or simplify this one. So clearly p is equal to 24x minus of x square. So here we got one function, that function that is equal to 24x minus of x square. So this is the function in terms of product of those two numbers. Now I will differentiate this with respect to x to get the critical point. Or first we will differentiate this. So here we are getting dp upon dx is equal to 24 minus differentiation of x square is 2x, right? Now to get the critical point, I should substitute dp upon dx equal to 0. So 0 is equal to 24 minus of 2x, because here I have substituted the value of dp by dx to get the critical point. So therefore take this 2x to this side. So clearly 2x equal to how much? 24, or what is the value of x? So clearly x equal to 12. So this is the critical point, right? Now we should check at this point the second derivative of this function is less than 0. If the second derivative of the given function at this point is less than 0, then the given function or the product of those two numbers gives the maximum or as large as possible. So therefore take the second derivative, d2p divided by dx square, that is equal to differentiation of 24 is 0. So clearly we are getting a minus of 2, because differentiation of 2x is minus 2. So clearly which is less than 0. Which is less than 0 means what is the conclusion? So clearly p is maximum. P is maximum at, or I will write p is local maximum. Local maximum at x is equal to, at x equal to 12, right? So and the value of x equal to 12, it represents the point of local maximum. Now we should find another number. Just you have to substitute this value in this function. So therefore to get the another number, x plus y is equal to how much? 24 is there. What is the value of x? 12. So therefore 12 plus y is equal to 24. So clearly y is equal to 24 minus of 12. What is the value of y? So therefore the value of y is equal to 24. And what is the value of x? It is equal to 12. So therefore sum of those two numbers, again that is equal to 24, and product of 12 into 12, that is equal to 124. That is the maximum product, or the product of those two numbers is large as possible. So such type of the question they may ask for 3 marks. Okay. Okay, right. The next question is question number 14, right? So here find the two positive numbers x and y such that x plus y is equal to 16 and x into y cube is a maximum. So here also we have to find the two positive numbers. They are x and y. Again here what are they given? They given the sum they are given, and x into y cube means they are given the product of those two numbers they are given. So here we should prove, or we should take this is maximum. This is maximum means a product of x and y whose second derivative is less than 0. By using the second derivative test, you should take or product of those two numbers at a second derivative, or second derivative that is less than 0, right? So here what they given, the solution is, so therefore x plus y is equal to how much they have given? 60 they have given. Okay, right. Now what is the value of x? So we will write like this: the value of x, that is equal to what? 60 minus of 1. Okay, right. And also they have given the product. So product of those two numbers, that is equal to how much they have given? X into y they have given. Okay. Now in this product I will substitute. So I will substitute the value of x. So what is the value of x? Or what is the value of x? So that is the 16, right, minus of 1 into what? Y cube. Okay. So again, now this gives the product of these two numbers. So now I will differentiate this function, differentiate with respect to y. So what you are getting? dp upon dy by dp upon dy is equal to, here you should apply the product formula. First function as it is 60 minus of y into differentiation of y cube is 3y square with respect to y plus, so y cube as it is into differentiation of this term. So differentiation of 60 is 0, differentiation of y with respect to y is, so clearly it is a minus of 1. Okay, now simplify this one. So dp upon dy is equal to, so here I will write a 3y square into 60 minus of y, and so clearly here it is a minus of y. Okay, right. So this is the first derivative of the product of those two functions. So here what I will write, so to get the critical point, right, to get the critical point, put dp upon dy that is equal to 0. To get the critical point, we should substitute dp upon dy equal to 0. So therefore in this equation 0 is equal to how much? So 3y square into 60 minus of y, right, minus of y cube. Okay, right. So simplify this one, or take, so here 0 is equal to, or here I will write like this, so 3y square into 60 minus of y minus of y cube equal to 0. Okay, right. So here, so multiply this, so here what we are getting, so clearly 180 into y square minus of 3y cube minus of y cube, this is equal to 0. Okay, right. So again 180 into y square, so clearly here it is minus 4y cube, that is equal to 0. Okay, and take y square outside, so here what you are getting, so clearly, or take 4, so here just take y square outside, so here we are getting 180 minus of 4y, this is equal to 0, or this product is 0, product of these two means either y square equal to 0 or this term equal to 0. So here y square equal to 0, or we will take 180 minus of 4y equal to 0. So this implies y equal to 0. So this implies y equal to 0. Or so here 180 minus 4y equal to 0. So this implies 180 is equal to 4y. So this implies y is equal to 180 divided by 4 means the value of y is equal to 45. Right? So here you should observe, here we got the two critical points. So here y equal to 0 and here y is equal to 45. So here we are not taking y equal to 0, because if you take y equal to 0, then the product of these two becomes what? 0. But what they mentioned, the product of those two is a maximum. So therefore, if you substitute y equal to 0, here the product is 0. So therefore, here we will take only y equal to 45. So therefore, now we should prove. So therefore, here we will take y equal to 45 is the critical point. So here we got y is equal to 45 is only the critical point. Now we should prove, or they given the product is maximum. Product is maximum means it's a second derivative at this critical point is less than 0. So for this we will take the second derivative. So therefore, is the first derivative, this one they have given, this one, that is a dp upon dy is equal to, so here it is a 3y square, or 3y square into 60 minus of y minus of y. Okay, right. Now we should find the second derivative. So therefore, again differentiating this, here we are getting a d square p upon dy square is equal to, so here we should apply the product form, or first we will simplify this one. So if you simplify this one, so here we are getting dp upon dy is equal to 180 into y square minus of 4y, because so after simplifying dp upon dy, after simplification of this, so here you are getting this result. right? So the same result here I have written 180 into y square minus of 4y. Now I will take the second derivative. So therefore d2p divided by dy square is equal to, right? So here it is 180 as it is into differentiation of y square with respect to y is 2y, right? Minus of 12 into y square. Okay, because so 4 as it is, differentiation of y cube is 3y square. 4 into 3 means 12. Okay, so simplify this one. So d, right? So this is equal to, so clearly it is a 360 into y minus of 12y square. Okay, right. So now we got the second derivative. Now we are proving that the second derivative is less than 0 because they only given the product is maximum. So therefore here we will take d square p divided by dy square at what is the value of y? Y is equal to 45. So 360 into 45 minus of 12 into 45 into 45. Okay, so here I will write 45 into 45 because 45 whole square. So therefore simplify this one or take 45 outside. 45 into, so here it is 360 minus 12 into 45. Okay, so here I will write 45 into 12. So here it is a 540. Okay, so clearly 45 into 360 minus of 540, right? So subtract 360 from 540, so 360. So here you are getting so here it is 180. So therefore, so clearly 45 into minus of 180. So clearly this is less than 0, right? So after substituting this, here 45 into this is a negative number. Negative number into positive number means we are getting negative only. So negative means this is a less than 0. So less than 0 means what is the answer? So P has local maximum. P has local maxima, right? At y is equal to how much? 45. So y equal to 45 means y is a critical point. Now we should find the value of x, right? So here after checking this, so here we got the value of y. So what is the value of y? So y is equal to 45, right? Now we want the value of x, so therefore put y is equal to 45 in this equation, that is x equal to 60 minus of y. Therefore x equal to 60 minus of 45. So what is the value of x? So clearly the value of x equal to 15 and the value of y is equal to 45. So here we should observe the sum of these two is 60. Sum of these two is 60 and the product of these two is maximum. So we have checked this by using the second derivative test, right? So up to this and remaining problems we will continue in the next class. Thank you.